So let's get started with this, and let's get started with var, which is kind of the oldest way, you could say, of creating variables in JavaScript. Typically, these days, we create variables with let and const, but it's important to understand that let and const weren't just introduced because they sound cooler. If they do, I'm not sure. But that there actually is a difference between var and let and const. And for that, let's start simple. Let's say we're having an age variable which stores a value of 30. Unsurprisingly, if I then console log age here, we will see 30 here. This is the log CodePen gives me here. Now that's of course not too surprising or too strange. The age variable which we create here is created as a global variable because it's created in our script like this. It's attached to the global scope, and anywhere in our script we can access it. And as long as we don't assign a new value, it will always hold that value of 30 here. Now that's the variable like this. It gets more interesting if we add a function. Let's say we have a function create char for a create character, and now in there we have that variable. Now if we try to log this here, we will actually see that I get an error here. Age is not defined. Now it makes sense because I never called that function, right? So let's call create char here. And still, we still get that same error. The problem here is that now this variable has a local scope because var creates lexically scoped variables. That sounds very fancy. In the end, it means that our variables are global if created outside of a function. If created inside of a function, they belong to this function and they can only be used from inside that function. So we can console log age here by saying inside of function. Here we can log this, as you will see. Here it is, inside of function 30. This is what's getting logged. Let me clear this to make it easier to read in the future. Console log down there will still not log anything. If I run this again, you see we get inside of function 30 and still that error for the log down there. Now what you can do, however, is you can access a variable that's defined in scope on a higher level, so to say. So if we had a global variable, let's say username, which is max in my case here, then we can indeed print this from in here, so from inside the function. This is possible. If you have a look at the bottom of the console here, we have inside of function 30 and we have max printed here. Let me remove that log which breaks everything because that makes sure that our output is more readable. So this works, and that's important to take away. With var, you have variables which have their own scope. If it's outside of a function, it's the global scope. Inside of a function, it's the function local scope. You can only access variables that have the same scope or a higher scope. So from inside a function, you can access the global scope, but globally, you can't access a variable that's only created inside of a function. If I, on the other hand, create a variable here, surname, like this, and I then change that in my function, Schwarzmuller, which is my name, and I then console log this thereafter, if I do this here, you see that here Schwarzmuller is being printed. So that is my console log statement at the bottom here, and it does respect the change I make to the variable here in the function. Why does this work? Well, I can log it here because it is a global variable and I'm trying to log it on a global level. This console log statement is not inside of a function, hence it's global, such as the variable, hence I can access it. And still I change it here because in the function here, I do work with that very same variable. I can access it because, as I just explained, from inside a function, you can access global variables, but you can't access local variables from outside of the function, but the other way around it works. So we can access this variable, and if we change it, we change the very same variable we're logging down there, which is why we see the changed value here. So this works. So you can always access something from a higher level and work with it or log it or whatever you want to do, but you can't access something from a lower level, from a lower scope, so to say. Now that gets especially interesting if we add a nested function, so a function inside of a function, which is something you can do. Let me get rid of all these log statements to clean all this output up. And now let's add a function here inside of this function. I'll name this configure char like this. And in there, I'll try to set the age to 31, and I'll add a new variable name or username here, which I'll name manu. Now that's very interesting because I have username up there too, and I try to access a variable which is part of a function, but of a different function, of the outer function. So let's see what this does. If I then call configure char, whoops, that should be char, not chart, and thereafter I console log age and I console log username, let's see what that gives us. It gives us 31 and max. Now that's interesting. 31 is the age I'm setting up in configure char. So I can access this variable even though it belongs to a different function. But I guess this makes sense, right? Because I mentioned that you can always access variables that are from a higher level, a higher scope. And this function has its own scope. This is a nested function, so we can't access the scope of this outer function. We couldn't access this variable or any special variable that's defined in here from this function though. And that's exactly the problem we have when we log username. Username is defined globally, so we can access it in both functions theoretically, and hence we can log it here. This happens inside of the create char function after all, and this works because username is a global variable on the global scope, and therefore we can access it. But when we change it here, when we create a new variable because we use a var again, then we actually create a brand new variable inside of the inner function, and that has its own value. We could access this variable here in the inner function as well, but we're not doing this with the help of var. We're creating a new variable. And inside of create char, when we try to log username, we can only access the outer one. We couldn't access the inner one because only from a higher level, and therefore we log the username we set up on that outer one and not manu, which we set on the inner one. If I did not have var in there on the other hand, we do of course log manu here, because then from the inner function we can access variables on a higher level, which means we can access this globally defined username. We change it in here, and whilst we couldn't access variables defined in configure char from inside create char, we can of course access username. This is changed in here. We can access it here, we log it here, and of course we log the changed value. So I hope this makes sense. You can always reach out to a higher level, but not to a lower level. Now that's var. Var can be especially tricky to understand if we have a look at a different example though. For functions, a new variable is created, as I explained and as I proved. Now this does not happen for if statements or loops. Here's a typical example which you see from time to time. Let's create a for loop with var. We have I starts at 0. We loop until as long as it's smaller than 3, and we increment it on every iteration. Inside of that for statement, I set a timeout here with a function. In that function here, I simply console log I, and I fire this after 1 second. Now, if we have a look at this, what this prints actually is 3 times. It does not print 0, 1, 2. Instead, it prints 3, which is actually our exit condition. So, which means it prints a value which we only reach because we exhausted our loop here. Now, why is that happening? This happens because we create a variable I here, and unlike functions, for loops or if statements don't create their own variables. Instead, this is simply a global variable. This is exactly the same as if we had this code here, and then we kind of would just set this to 0 again or anything like that. So we create a global variable here, and if this were inside of a function, we would create a local variable exclusive to this function, but we would never create a special variable for the for loop. And what this means is that inside of the for loop, this code here runs for every iteration, and what it does is it registers a callback. It registers a function which it runs in the future after 1 second. Now, the loop, of course, doesn't wait for this to finish. It doesn't wait for this to fire. It just registers this and continues with the next iteration. So when the loop is done, it registered 3 callbacks. It registered that this function should be executed in the future in 1 second, 3 times. That's what happens when that loop here is exhausted. It does not wait for this to be done. It does not wait for a second before it moves on to the next iteration. Instead, the way JavaScript works, and this is totally unrelated to variables, is that this is simply registered as a to-do task in the future, and then it continues with the code. So we have this function to be executed in the future 3 times, and we log I here, and since I is a global variable, we change I and we refer to the latest value of I here when that second is over and when that function, that timeout function, executes 3 times. That's why we print 3 times. And this is the best way to now move on to let, because that's where let is different. If I add var here again, just because it's a bit shorter, then we have that behavior I just explained. And now watch what happens if I change var to let. With that change, what you get is 0, 1, 2 instead of 3. That's the old log up there. 0, 1, 2 is after I changed this to let. Now why does this happen? Because let uses block scope, not lexical scope. That means that let does not care about global or local. It does not care whether you're inside of a function or not. Instead, it cares about the block in which you are. And a block is basically anything with curly braces. That is a function, but that also is your for loop or your if check. This loop receives its own variable, and that same variable is then changed for every iteration, but the function in the timeout locks in the value of that iteration in which the timeout is registered, because it's a closure in the end, which we have here. It captures the variable value at the point of time this function is created, which happens when we register it as a timeout. But it's one variable created for that for loop, one variable which we then change with every iteration. And this is a special behavior you get with let, with block scoped variables in for loops like this one here. It's a special intended behavior, which is part of the ECMAScript standard, that you have this behavior in for loops instead of the behavior you saw with var. But it's also important to understand that let is not just there for loops, but for whenever you want to have a variable scoped to its block, so to its surrounding curly braces, be it an if statement, a for loop, a function, whatever it is. Block scope variables also are never globally registered. You can have them in a global context here, you can have them outside of a block, but then there's like an invisible block around them in the file where you're writing your code. They're not registered on the window object as var variables actually are. So every block, and that's the thing with the curly braces, receives its own variable, and still we can access variables from a higher block, which is why from inside this function we can access this variable. We're not defining it in this function, but we're defining it in the outer block, and we can access it. But we lock this value in. We're not having that global variable, which gets changed all the time. Instead, we have the locked in value, because that's what let does, and that's where it differs from var. Technically, it's block scope instead of lexical scope. The best way of understanding it, I think, is an example like this here, where you can really see the different behavior and that you now have more than just global or functions. Instead, you have anything with a curly brace can get its own variables. You can still access variables from a higher level, from a higher block. You can't access variables on a lower block, but you're not restricted to functions or global. So that's let. It leads to this output. Now what happens if we change this to const? Then I actually get 0, but then I get the error assignment to a constant variable. We get this error because what we now do here is we create a constant, and this constant is therefore created for this for loop, and now we try to change this constant for every iteration. And the idea behind const is that you mark a value as unchangeable. It won't change. And that's exactly what we try to do here, though. We try to change it in the second iteration and the third iteration. And that's why we get this error. So const is not really a good match for this code here. There you want to use let. But const is great whenever you write code where you know that you have a value which you won't really change. And of course, you might wonder, why would I store a value in a variable if I never change it? It's not a variable after all then. Well, that's true. You could do this for readability. Of course, you can always hard code the values which you never change in your code. But it might make your code easier to understand if you split it in multiple lines and you have variables that store some core values of your code. In addition, not all code is hard-coded. Maybe you're getting this from a user input, which you select with query selector input value, something like this. Maybe this is how you got that value, and you want to store it in a variable because, yes, you could drop it in here, but maybe you use the username in multiple places of your code, maybe in another place where you don't just log it, but do more useful things with it. Well, then it could be a good thing to register it once and reuse it. You never change it, but you use it in multiple places. That's also a good reason for using a variable. However, this, of course, isn't really a variable, it's a constant. Whenever we try to change it, so whenever I try to set this to, let's say, menu, we'll get an error that we're not allowed to assigning to a constant variable. Constant variable sounds a bit strange, but that's what it is in the end. So const really is there for us to force us to write cleaner code. You could always use let in places where you use const. Const is never a must use from a technical perspective, but it can lead to cleaner code because you will get an error if you try to do something like this. And that might be what you want. You might want to avoid mistakes like this, where you reassign a value that shouldn't really change in your code. It makes your intention behind your code clearer. If you're working in a team and someone sees that code, it's clear that username probably shouldn't change in that code. So it can simply lead to cleaner, more expressive code that's easier to understand. And that's why you would use const. Now, there is one special thing about const which can be hard to wrap your head around when you see it the first time. Let's say you have const user, and user actually is an object. It's an object where you have a name property which is max or anything like that. Now, unsurprisingly, if I console log user here, we'll see that object being printed here. Now, if we set user to a new object where the name is menu, we'll get an error because we're trying to assign to a constant variable, and as you learned, that's not something that works. What's strange though, you'll not get an error if you set user name to menu like this, or if you then also maybe add an age like this. Instead, this works and prints the new object. Why? Because this is not a new object. What const in the end does is it yells at you if you ever take that variable and try to assign a new value with the equal sign. So whenever you use the equal sign after a const variable, you'll get an error. But we're not doing that here. We're using the equal sign, but we're not assigning a new value to user, but to a property inside of user. And that has something to do with JavaScript knowing reference types and primitives. And I have a separate video on that where you can dive in deeper. The thing really is, this object here is created once and stored in memory, and what user stores here, this variable, is a pointer at that object in memory. Now here, I then access this object and I access a specific property and I assign a new value to that property. That means that the object itself, of course, kind of changes. It now occupies more space in memory, probably, or it gained an extra property. But what we stored in user, the pointer, is still the same. It's the same object in memory. It got a bit bigger, it got a new property, but it's the same object. And therefore, the pointer, the address of the object in memory, is still the same. So the value in user didn't change. That's why this works. Now that we learned about these three different ways, the obvious question is, which way should you use for creating variables? And the answer is, use let for variables, use const for variables that shouldn't change, so for constants. Don't use var. Var is old school JavaScript and there really isn't a reason to use it anymore. You can do the same thing in better with let, and very, very, very rarely would you want one of the special behaviors of var in modern JavaScript applications. Typically, there are better ways, and let simply allows you to write cleaner, more straightforward, and also more predictable code. So let for variables that change, const for variables that don't change. So I hope this was helpful. I hope this helped a bit with understanding var, let, and const. There is more you could dive in. We could dive into hoisting. We could dive deeper into closures, and these are all topics I might cover in the future. And you can definitely explain all of that in more technically correct terms. I hope this was helpful in understanding how it works, though, and I hope you got a lot out of the video. Hopefully see you in future videos too. Have a great day. Bye.